Hi, I'm Gordon, and in this video I'm going to be taking you through a data science project, more specifically a natural language processing project. And the text data that we're going to be working with comes from a collection of scouting reports. And I'm on right now a website for FC Hockey. It's NHLentrydraft.com. And this is an organization which employs professional scouts who write up their reports on players. I am actually a subscriber to this organization, but right now I am not signed in specifically because these reports that I'm about to click on here they exist behind a paywall. So what you're seeing right now is what you can find on this website simply by visiting it yourself. I'm also using some scouting reports collected by Corey Pronman and Scott Wheeler, both of whom currently write for The Athletic. Those exist behind paywalls as well. I will be quoting one report soon, simply to give you some context for what these look like in their totality, but I will avoid exposing too much of this work as I go through my project, as the point here really is not to talk about NHL scouting, but rather things that we can do in natural language processing, particularly in the domain of written expert opinion, which is what we're working with right now. So what you're looking at right here is one example of a report, and obviously it's not the entire thing. But there are hundreds of these, and I've collected over 1,300 to use in this project. Okay. And as we get into this project, I'm going to start by providing one full example of a report, and this comes from Corey Pronman's 2017 draft ranking. Let's just take a quick look at this. The report that I had up on the screen just a moment ago, you may have noticed there was an indication of the position played by the player. And in many reports, it's common for them to explicitly say, this is a puck-moving defenseman, or this is a skilled winger, or whatever it is. In a lot of reports, however, there is no explicit designation as to the position played by the player. And this makes sense for a human reader if that is made explicit, perhaps in the heading describing the player, or maybe somewhere else. We don't always need, we don't have to be constantly reminded of the position. And what I have up on the screen right now is an example of one such report where I would suggest it's, if you, even as a human reader, if you read this and you don't have that context for the position that the player plays, you've got to make some inferences based on the words that you're seeing. And I've highlighted specifically the words that suggest to me the position that this player plays. I would suggest that this is a forward based on how much we're talking about scoring, playmaking, skill level. And these are certainly not things that are restricted to describing forwards. You might see them in a description of a defender, but they're just more common here. In yellow, I've also highlighted some things that I would suggest more often are discussed when we're looking at defenders, risky mistakes, for instance, and to a lesser extent, a discussion about vision. But with defenders, you'll often hear a scout talking about their vision or their, first pass, that kind of thing. Anyway, let's take this down here. And what, the purpose of me showing you that report, what I want us to be thinking about as we dive into this project is whether or not it's possible for us to construct a model that can, read these reports and infer the position that the player plays. And spoiler, the answer is yes, we can. And what we're going to be doing here to execute that is using a term frequency times inverse document frequency method, which, if you're familiar with any of the history of natural language processing, is a very old and standard method of for instance, organizing searches, that kind of thing. We're going to use a TF-IDF method to create a vectorized representation of our text, and then we will construct a very simple neural network classifier, which will tell us either that the player is a forward or that they're a defender. All right, let's jump into this, and I'm loading these packages that you see on the screen. I will share with you, you don't need all of these if you're hoping to follow along with this project. I will use all of them in future videos where we'll be working with the exact same collection of text and performing an aspect-based sentiment analysis using a topic modeling method combined with a sentiment analysis method. And again, before I dive in, I will just reiterate that really the purpose here is to explore the things that we can do with the existing tools for natural language processing. And I think it's pretty illuminating. So here are a few, I've already gone through these as far as this session goes from my notebook, but I'm going through these and showing them so that anyone who wants to follow along with this code can. And I've uploaded my CSV file. We'll go ahead and take a quick look at what's located here. I collected this myself. This data set does not exist anywhere in the world. And again, the information that I've got here is all paywall protected, so for that reason I won't be sharing it. But you can see I've got the names of the players, the reports themselves, and then whether or not they're a forward. So 0s for defender, 1 for forward. All the other information I have here, a lot of it's actually outdated at this point and is not relevant to the project that we're undertaking right now. So for pre-processing, we're going to do some really standard things here. Pre-processing when you're working with text data as opposed to a collection of bank loan applications or whatever it is, numeric data, more traditional forms of data, right? When you're working with text data, there's not a standard practice. There are some things that we pretty much always do, but there's no one way to do things, and it's really more a matter of do what works. In this case, I'm going to be removing punctuation, removing anything that's not an alphabetic character. I'm also going to take out the shorter words, and that's something that I've simply discovered through experimentation is useful in this case. I think that's frequently the case, but again, it's really going to depend on the language that you're working with and the corpus of documents that you're working with, the occasion for writing, etc. I'm also going to remove stop words, which, stop words, if you're unfamiliar with them, they're filler words, right? The word to, I believe, would fit in there. It's a word that's necessary for human communication based on our natural language rules, but the word to doesn't have much contextual value for a computer program trying to read text. I'm also going to make everything lowercase and remove the names of these players. So let's get started with this code. We'll go through pre-processing in this first video, and then in the next one, I will actually construct the neural network classifier. So first, I'm just going to go ahead and create 2 lists of first names and last names, and then using this list comprehension method, I'm going to, well, first we're pointing to the columns in the data frame, I should say, and then using this list comprehension method, we are creating lists of the first names and lists of the last names. We're then going to transform these into just a big string that contains everything for first names and last names. And here we're writing our report cleaning function, right? This is really standard issue stuff that we're doing here. But if you're interested in reading, or if you're unfamiliar with the code that I'm working with here, a couple of resources that I really would highly recommend. Natural language processing in Python is a text out there that's available. That's the first one that I ever worked with. And I believe they go through a lot of the NLTK or Natural Language Toolkit basics in that text. It's very useful. We're using the Natural Language Toolkit for just about everything in this project. I would also recommend, there are certainly some online resources that are fantastic. Alice Zhao has a series of YouTube videos that are really useful. We'll actually talk a little bit more about her work in another project that I'm doing, where I'm using essentially the exact code that she shows. Anyway, let's go through this really quickly. We're splitting on the words. This is the function, again, that we're going to use to clean up all of our reports. And then we're going to the regular expression module right here. And we essentially are removing certain punctuation, right? And we accomplish that with these 2 lines of code. And we're, in Python terms, we're saying, hey, let's go ahead and substitute nothing in for any of the punctuation that we don't want. So we're just removing it, in essence. We're also taking a look at anything that's not an alphabetic character and pulling it out. Okay, so we're saying, okay, we're limiting the words that we're working with to only those that are alpha. And we're also taking out the short words. We're making everything lowercase. And then we want to go ahead and pull out stop words, and stop words have been pre-identified by the Natural Language Toolkit. You want to specify English. There are a few different languages. Obviously, English is what we're working with here. And then we are going through and removing the first names and the last names as they appear in the text. And you'll notice, well, if you may notice, you may not, but I'll just go ahead and tell you in advance. Some of the names are going to slip through, especially in instances where it's, a possessive case, if they're referring to someone by their last name using the possessive case. And, if the name was McDavid and it's described as, McDavid's offensive play, in that case, the method that we're using here is not going to recognize that that's a name. It's going to leave it in, and that's okay. We don't have to get everything, but these names in this case are really just a noise factor that we're trying to reduce. And I don't know if I ran this already, but I'll run it now. Next thing that we want to do is go through and create a list that contains all of the reports. That's what we're accomplishing right here. We're iterating through the data frame that we just created and saying, let's go ahead and get all those reports and place them in a list. Just as proof of that, I will show you. Here we go. And obviously this hasn't been processed yet. We still see all of the things in there that will eventually be removed. There we go. Just want to get rid of that. And now we are applying the function that we wrote earlier for cleaning the reports. And when this is done, we can take a peek now at the processed version of our text. Oops. And we should be seeing essentially a giant list of lists, right? So this, for instance, is the beginning of someone's report. And these are the words that we care about, the things that remain in that report. You can't exactly read this very easily without making some guesses as to what's been taken out. But it looks like this player would be nephew of former Devil Bobby Holik, I think is probably what that's suggesting. And it would look to me like he's a defenseman. Anyway, that's what we have there. And we need to do one more thing here. Let's go ahead. I'm going to show you. We want to transform this list of lists Okay, and what we're getting here is all of the same words, but in a different, more workable form. Okay. And I guess let's talk about this really quickly. I don't want to belabor the point, but we're saying, okay, for each element in that processed text, which would be a list within the larger list, for each element in the processed text object that we created, we want to point to a temporary, we're saying, okay, we're saying we want to point to this as a temporary object. This is the first element in that larger list, and it's the very first report, right? Simple enough. And then I'm saying, okay, well, so now for every word, or rather we want to iterate through every word in that report. And now we're saying, okay, the temporary object that we're creating here is a space plus the first, or the word that we're on for that report. And we're saying, let's append to this empty list of final text that temporary object. So I'm explaining this in a very poor manner, but what we're doing is we're iterating through the list of reports that we created, and we're saying we're going to now piece by piece append every individual word to this new list of strings that we've created. Yes. Okay. Terrible explanation, but it doesn't matter. Let's move on. What we've got now is a suitable basis for creating a term frequency inverse document frequency matrix. Okay, and how do we do this? We imported at the beginning a TF-IDF vectorizer, which we're going to use now. And I'm just going to say vectorizer to TF-IDF vectorizer, which we imported earlier. Again, great. Now we have to specify the n-gram range. And if you're unfamiliar with this, n-gram is just how many words can be combined. So, are we interested in each individual word as its own token going forward, or are word combinations of interest to us here? And having done this a few times, I can tell you that the n-gram range that we want, here we go, is just 1. And this is how we specify that. We want to be looking at each individual word on its own, not word combinations. Okay. And now, now we need to take that vectorizer object and say transform that object that we just created. All of that pre-processing that we did is about to pay off. We're going to make a data frame. And I'm going to have to look at a resource to remember all of the code for this. Bear with me. In this case, I need to do one more thing before I can do this. I want an index in this data frame to show the names of the players. So I need to do this. I need to do one more thing. I apologize. I'm getting ahead of myself here. Oh, now I'm saying, okay, let's go back and iterate through that original data frame again. I should have done this earlier. Data, we want the name of the player, so we need to say full name. Full name. That location. Oops. There we go. And now we're saying, okay, go ahead and append that as you're iterating through everything. Each time, append it and that object to this list. Okay, I did that. Didn't do that right. Names equals a list. There we go. And now coming down here again, I'm just going to say index equals names. Great. Keep this as short as possible. And yeah, I'm one mistake here. Okay, so that should have created our term frequency times inverse document frequency matrix. Lo and behold, it did. And what are we looking at here? We're looking at the term frequency inverse document frequency scores per document. Okay, so if these words don't appear anywhere in this report, we should see zeros, and we do. But if they do appear, then we should see their value in terms of term frequency times inverse document frequency. And without doing a whole lesson on what TF-IDF is, if you're unfamiliar, mainly what you need to know is that it's literally term frequency times inverse document frequency, which if you think about it is going to provide you with some measure of how, or in theory, it provides you with some measure of how much of a document how much of a document's uniqueness can be described by a single word. So if a word is extremely common and it shows up in your document 5 times, you still might not have that high of a term frequency inverse document frequency score. But if you have a word that is rare and it shows up in a document even once, you might see a higher term frequency inverse document frequency score. Or in some cases, if it just shows up a bunch of times in a single document, even if it's maybe a little bit common, you could see a high score there as well. All right. These scores at this point they provide us with a sparse matrix. Most of the values in this matrix are 0, as you can see, and the other values that do exist are really low. The value that we have here, though, is we've now got some data that we can feed forward into a neural network. And I'm going to cut this video off here because I've let it go on really long. But in the next one, we will actually use this data that we've created as the basis for a neural network that can tell us whether these players are forwards or defenders. Thanks so much for listening. Look forward to the next video.